Okay, so we're starting some of Chapter 8. Our first section is 8.1, defining and using sequences in series, and basically all of what Chapter 8 is about are patterns, okay? And so before we get started looking at a couple different examples of the patterns you're going to see, let's define a couple things when it comes to sequences. And our first definition or bullet point talks about that a sequence is a function whose domain, which are your x values, is a set of consecutive integers, domain. And so we'll get more into what exactly that means when we get to our example problems. Our second bullet point says if the domain is not specified, it is understood that it starts with the number 1, which is super important that you realize that. Starts with the number 1. The values in the blank, which they're talking about your y values, are called the terms of the sequence, and that's the range. So the values in the range, and I know we're pretty familiar with domain and range after our last unit in Chapter 6, where we talked about domain and range of our exponential graphs, our exponential growth and decay graphs. And so then your last bullet point says a sequence can be described by an equation or rule, and that's one skill we will also practice. Now there's two types of sequences. A finite sequence has a limited number of terms. You can think of it as a sequence that stops. And then you have your infinite sequence. Oops, let me spell this right. Infinite sequence continues without stopping, okay? So without stopping. Let me show you the first type of problems that we'll be responsible for in this section. This one is about writing terms of a sequence. And so what happens is they give you an equation or a rule. This is our equation or our rule, and we are asked to write the first 6 terms. So how that looks, let me get rid of this so I have more space on my first line here, is you want to consider that when, right now it says a to the n, or I should say a sub n. That n represents the x values or the domain you're allowed to plug in for the n here. And keep in mind, this did not specify what number to start your domain at, what number to start with your x values, so you assume that you start with 1. So what you would want to do is you'd say, when a is 1, I would then take my equation, and in place of n, I'd put a 1. And then you would calculate. And so 2 times 1 is 2 plus 5 is 7. And you would do this for all of your values because they want the first 6. You would do this for 1 through 6. So let me write these out and then we'll go through and do them. So if we're plugging in a 2, we would have 2 times 2 plus 5. 2 times 2 is 4, 4 plus 5 is 9. So our when a is sub 1, we get out a 7. When a is sub 2, we get out a 9. So basically then our numbers that we're getting out, those are called our terms. So the first term of our sequence is a 7. The second term of our sequence is a 9. When we calculate our third term, we'd have 2 times 3 plus 5. 2 times 3 is 6. 6 plus 5 is 11. We calculate our fourth term. 2 times 4 is 12 plus 5. Sorry, 2 times 4 is 8 plus 5 is 13. Calculate our fifth term. 2 times 5 is 10, plus 5 is 15. And then our sixth term is 2 times 6, which is 12, plus 5, which is 17. And that would conclude that example. All you're doing is writing the first 6 terms. These numbers that you're getting out, those are your terms of your sequence. All right, let's try number 2. So same idea. For number 2, we have to go through and we're going to plug in a 1. That's going to be our first term. and we're going to see what we get out. So when we plug in a 1, we would have, and really what you want to look at, I should probably go back and fix this, is I wrote a sub 1. Well, you can see it written two ways. You might see it, like in our first example, where it was a sub n, and you plug in for n, the 1, the 2, the 3, or whatever. But then you're also going to see it this way, written kind of like you're probably more used to seeing functions written f of n. It means the same thing. Wherever you see that n, you're going to plug in your number, your numbers 1 through 6. So we'll write it this way then. F of 1. What that means is in my equation, I'm going to plug in a 1 for n. So we have -3, parenthesis, 1 minus 1 equals. So what you have to do is 1 minus 1 is 0. And so if you have -3 to the 0 power, that's going to give you 1. Plug in a 2. -3, 2 minus 1 equals, and so 2 minus 1 is 1, -3 to the first is -3. Our third term, so we're plugging in a 3, would be -3 to the 3 minus 1 equals, so 3 minus 1 is 2, -3 to the second is a +9, so be careful, use your parentheses. So a negative number to the second power is still positive, so +9. F of 4 is -3, 4 minus 1. 4 minus 1 is 3. -3 to the third power is -27. Plug in a 5. That'll be -3. 5 minus 1. 5 minus 1 is 4. -3 to the fourth, this will be a +81. And then plug in a 6. -3. 6 minus 1. 6 minus 1 is 5. So -3 to the fifth is -243. And that's all you have to do. We wrote out our 6 terms, right? So the number 1 when we plugged in represented our first term. We got out a 1. So these are the first 6 terms of our sequence. All right, couple more to try. So you can work ahead of me or you can follow along with me, but we're doing the same thing for these next 3 examples. And we're going to continue to write out terms 1 through 6. So your first one's not too bad. Again, it's written in the form of a and then the sub n. So we want to plug in a 1 for our first term. That 1 is representing our first term. And when we plug it in, 1 plus 4 is equal to 5. So our first term of this sequence is a 5. And then we'd plug in a 2. And we'd have 2 plus 4 is equal to 6. So our second term is a 6. Plug in a 3. 3 plus 4 is 7. Our third term is a 7, and we just keep on going. Plug in a 4. 4 plus 4 is 8. Plug in a 5. 5 plus 4 is 9. And plug in a 6. Add it to 4 to get 10. And so that problem is complete. We wrote out our first 6 terms of the sequence. All right, on to our next example. Again, feel free to work ahead. You could always stop the video at this point, work through them on your own, and then kind of fast forward on the video just to look ahead to see if you had the right answers. This one's written more in like the function notation. So we have switched over to erase. F of 1, so 1 is representing what term are we on. This is term 1, equals -2. 1 minus 1. So we plugged in a 1 for n. 1 minus 1 is 0. Anything to the 0 power is 1. You guys probably have that memorized by now. Then we plug in a 2. -2. 2 minus 1. So 2 minus 1 is 1. -2 to the first power is -2. Plug in a 3. -2, parenthesis, 3 minus 1. 3 minus 1 is 2. -2 to the second is going to give you that +4. Be careful. Use parentheses when plugging this in. Okay, fourth term of the sequence. negative 2, 4 minus 1. 4 minus 1 is 3. Negative 2 to the third power is a negative 8. Plugging in a 5. Negative 2, 5 minus 1. 5 minus 1 is 4. Negative 2 to the fourth power is a positive 16. Then your last one, f of 6. So our sixth term of the sequence, negative 2, 6 minus 1. 6 minus 1 is 5. Negative 2 to the fifth power is going to be a negative 32. All right, that example's done. Last one over here. Be careful with the fraction. We're going to start off with our first term. So a sub 1 is representing the fact that this is our first term. Unless specified, always assume you're starting off with plugging in a 1. So we would have a 1 on the top and then over 1 plus 1. That's going to give you 1/2. Okay, so for our next term, we're going to have a sub 2 is equal to, now be careful, there was an n on the top, so that means we have to plug a 2 on the top over 2 plus 1. So that'll give us 2 over 3, 2/3. For the third term, a 3 on the top over 3 plus 1, and that will be 3 over 4, 3/4. Fourth term, 4 on the top over 4 plus 1 will be 4 over 5, 4/5. 2 more to go. A sub 5 is representing the fifth term in this sequence. We will have a 5 on the top over 5 plus 1, giving us 5 over 6. And then our last one, a sub 6 equals 6 on the top over 6 plus 1, is giving us 6 over 7, 6/7. So those are the two types, or I should say the first of the two types of problems you're responsible for. When you're given an equation or a rule that's representing a sequence, can you use your domain numbers, which for the most part we're going to tend to start at 1 unless it's specified otherwise, and then write out the terms for however many is being asked. It's not always going to be write out 6 terms because it's quite a bit, but can you write out the, can you write out the first 3 or 4 terms, or even maybe just the next term? So that's the first type of problem, and then let's go on to our next type. This is where, let's zoom in here, you are given, let me straighten this out. Now this time it says describe the pattern, write the next term, and write a rule for the nth term of the sequence. So basically what you have here is you have your pattern and you have these terms. These terms are your y values. And so you have to remember it wasn't specified that we started at anything other than x being at 1. So what you're really looking at here is you're looking at when you plugged in, let me move, hold on 1 second. I want to make sure you can really see this. Move this over a little bit. So basically when we plugged in a 1, we got out a 3. When we plugged in a 2 into this pattern or rule, which we don't know, we're trying to figure out, we got out a 4. When we plugged in a 3, we got out a 5, and when we plugged in a 4, we got out a 6. So keep in mind you have to do a couple things. First thing we want to do is we want to describe the pattern. And so what you can describe is just, what are you noticing? What are you seeing? For example, I might say that the pattern is starting at 3, starting at the number 3. When I plugged in a 1, I'm getting out a 3 from this pattern. I might say that I notice it is increasing by, if you notice 3 to 4, 4 to 5, 5 to 6, it's increasing by 1. So then you can probably figure out just from what you're seeing, what the next pattern of the sequence would be. The next term would be a 7, right? 1 up from 6 is 7. But what the hardest part is writing out the rule. And so what we want to look at is what is happening every single time. We want the rule to be written with a variable in it so that we can plug in our 1 into our variable and get out a 3, plug in our 2 into our variable and get out a 4, plug in our 3 and get out a 5. So you have to think, what is happening? What am I doing to 1 to get a 3? I have to do that exact same rule to 2 to get out a 4. into 3 to get out of 5. So I know I'm kind of repeating myself, but that's basically, that's what you have to look at. You're trying to pick up the pattern. And so for the rule for this problem, you're going to write it as, oh, hold on, let me put this back. Okay, you are going to write it as a sub n is equal to, now n is our variable, and n is the number that we are plugging the 1, 2, 3, 4, and so on into. So this rule would be written as n plus 2. I'm plugging in a 1 for my n. 1 plus 2 is getting out, I'm getting out that 3. When I plug in a 2, 2 plus 2 is giving me that 4. Plug in a 3, 3 plus 2 is giving me the 5, and plug in a 4, 4 plus 2 is giving me the 6. So these are the things that you need for these problems. Describe the pattern, what is the next term, and then write the general rule that's describing that pattern, and that general rule has to contain the variable. So when we look at our next example, if you notice, keep in mind you're always starting with 1 unless it's specified otherwise. So when you plug in a 1, I'm getting out a 1. And when I'm plugging in a 2, I'm getting out a 4. And I'm plugging in a 3, I'm getting out a 9. And when I plug a 4 into this rule, I'm getting out a 16. And I hope that from all the work we've done, this one almost sticks out at you. And before we get into what is happening in this pattern or writing down the next term, we should write down like what we're noticing, a general observation. And so what I notice is if I'm going from 1 to 4 to 9 to 16, you can write something as basic as quickly increasing. Quickly increasing. And from all the factoring work we've done, this entire semester, I hope you are able to realize that these numbers are perfect squares, okay? So that's something else you could even write for your pattern. You could write perfect squares. Oops, SQUA, perfect squares. And so your next term is going to be 25. But then when you go to write your rule, you have to be careful because your rule has to have the variable so that when we plug in a 1 into our variable, we get out a 1, and 2, we get out a 4. And so, every single time we plug in a number, we are squaring it. And so your general rule is written as a sub n is equal to n to the second power. And that's how we're getting all of our numbers. If we were to plug in, like they asked us to describe, plug in a 5. Oops, I keep switching out. Sorry, the writing utensil. Plug in a 5, we should be getting out the next number in our sequence, which was 25. So that's your general rule for a pattern like that. Okay, on to the last one. What we want to look at is I always like to really take a close look at the pattern and keep in mind, I want to remind you, you're starting at 1. So when I plugged in a 1 into my new rule or pattern, or I guess you can think of it as an equation, I'm getting out a -2. When I plugged in a 2, I'm getting out a -4. When I plugged in a 3, I'm getting out a -6. Plug in a 4, getting out a -8. So as far as the pattern goes, you can, again, you just make some observations here. The pattern is, you could write down that we are starting at -2, and you could have even mentioned what number you were starting at in our second example. You could have said, we wrote down perfect squares in quickly increasing. You could have put, we are starting at 1 and, quickly increasing from there. There's a number of different things you can write down for the pattern. I just want you to practice writing down just observations. What are you seeing? And so in this number 3, we're starting at -2, and then you can talk about is it increasing or is it decreasing? And if you look at it, we're continuing to be negative. So we are decreasing, starting at 2, comma, decreasing. And you can even be specific as to how much are you decreasing each time. Decreasing by 2 each time. Just make some observations, all right? So your next term then, if we're going -2, -4, -6, -8, your next term is -10. And then you have to think, though, we need to write this rule. And your rule has to be with an n or a variable in it. We tend to just use n for these series and sequence problems. And so you have to think, what am I doing to the number 1? Here, let me put it on the laser. What am I doing to number 1? What kind of math am I doing to that to get out a -2? Whatever I did to the 1, I have to do that exact same math to 2 to get out a -4. That same calculation I need to do to 3 to get a -6, and that same exact, again, calculation to the 4 to get out the -8. I know I'm being very repetitive, but I think this is the most difficult part, is writing these rules, writing these equations. And so what you want to realize is that for this example, you are multiplying by a -2 each time. So you could write it as negative 2, n. Plug in, for your plugging in your 1 here, for the n, negative 2 times 1 gives me negative 2, the first term in my sequence. Plug in a 2 here, negative 2 times 2 is a negative 4, second term in my sequence, and so on. So that's how we write the general rule, and a lot of times it just takes practice, because that's probably, of all the 3 things I'm asking you to do here, pattern, next term, or the rule, the general rule tends to be the most challenging. So I hope these notes helped. I can answer any questions when I see you guys tomorrow, and get started on the homework. Thanks, have a great day.